Motion. Our learning objective is to obtain, evaluate, and communicate information about the relationship between distance, displacement, speed, velocity, and acceleration as functions of time. Let's look at this learning objective in more detail. So we want to focus on communicating the information about the relationship between the distance and displacement. So we're going to focus on distance and displacement. Let's get started. Let's start with position. Position is the location of an object with respect to a reference point. Like 0 on this number line is the reference position. Einstein is at 2 meters. His position is plus 2 meters with respect to the reference point on this number line. Einstein is 2 meters to the right. Let's look again at Einstein's position at 2 meters to the right of the reference position. If Einstein moves to negative 2 meters of the reference position, Einstein's position has changed. So Einstein moved from 2 to negative 2. This is our change in position, where the delta symbol is a Greek symbol that means change. The change in position, delta x, is equal to the final position, xf, minus the initial position, x sub I. The delta is change, f is final, and I is initial. So let's look at how we can use this to determine the change in position of Einstein. So our change in position, delta x, is equal to our final position, which was negative 2, minus the initial position, which is a positive 2. This gives us negative 4 meters as the change in position of Einstein as he moves from the positive 2 meter position to the negative 2 meter position. Displacement. This is the change in position of an object with respect to a reference point. So when Einstein moves from the positive 2 position to the negative 2 position, the displacement was negative 4 meters. Distance. This is how far an object moved. So in this case, with Einstein starting at positive 2 meters and going to negative 2 meters, the distance he moved was 4 meters. From 2 to 1, 0, negative 1, negative 2 is 4 meters between. Now let's look at displacement versus distance. Back on our number line, we have Einstein at negative 2 meters. And now he's moved to positive 2 meters. What's Einstein's displacement? What distance did he move? Remember that displacement is the change in position, delta x. And on our number line, we had a position 0, reference position here, and Einstein was over here at negative 2 meters. And then Einstein moved and was later over here at a position of positive 2 meters. So if the change in position, delta x, is equal to the final position minus the initial position, then our change in position would be equal to final minus our negative 2 as our initial. And this would give us 2 minus a negative 2, which is 4 meters. Now, displacement is different from distance. Remember, distance is how far So when Einstein moves from -2 meters to +2 meters, he passes the -1 meter mark, the 0 meter mark, the +1 meter mark, and then reaches the +2 meter mark. So if we count the meters traveled, we have 1, 2, 3, 4 meters total distance. So our displacement is 4 meters and the distance is 4 meters. Now what if, instead, Einstein is here on our number line, where we have the reference position in the middle, so x equals 0 here. And let's say that's where Einstein starts. So Einstein is initially at x equals 0. And let's say Einstein moves then to the right, to the +3 meter mark, and then moves back to the left, back to the 0 meter mark, back to the reference position. So if our x initial is where we started, and our x final is where we end, then our displacement calculation is the final position minus the initial position. So delta x will equal 0 minus 0, or 0, no displacement. However, let's look at distance. Einstein moved 3 meters and then moved back to 0 another 3 meters, for a total of 6 meters. Important thing here we see is that displacement is not equal to distance. This video is made using Google Slides, Explain EDU, and Screencast-O-Matic. Thank you for watching.